Guys, I'm really excited to bring you the last episode in this series. Hey, I'm Adam, and welcome to the final episode of the Nibbles tutorial, where we complete the classic snake game with C++ and SFML. Hey, it's Adam. Welcome to the final episode of the Nibbles tutorial, where we complete the classic snake game with C++ and SFML. In the last episode, we set up game states, allowed pausing and restarting the game, handled collision detection, and loading levels from files. In this episode, we will bring it home by adding some scoring and write some text to the screen, including creating that game over screen. At the end of this episode, I will give you some homework tasks, some ideas you can use to help solidify your understanding by making some changes to the game. If you have trouble with any of this, or would like to offer support to other people, then please consider joining the community at forums.caf.tech. I look forward to seeing you there, and I'm super keen to see you post your homework code. Now let's get into it. I want to start by tracking the score and some other stuff. So we want to write text to the game window. Now the way that we do that is actually a bit verbose. So first we'll create a function to consolidate some of that work and reduce our duplicate code. Let's start in engine.hpp. We'll create a new function called setUpText. It'll be a static setUpText. It'll take a few parameters. It'll take a pointer to the actual text item so we can modify it. Take a pointer to a font. We'll set up fonts as well. Take a string value to actually show which text we're going to put, like, game over. The size of the font. And a color. Notice I put the variable with COLOUR. That's how we spell it here. Alrighty. In engine.cpp, let's set up this function. Let's do it here above the level stuff. Set up text. So we'll take text item, set font to the font that we gave it. Text item, set string to the value we gave it. Set character size to the size. Set fill color to the color. Now, it seems like it doesn't do much because we're just passing all the information that we want to set to it anyway. But every time we want to create a text item, that's every item of text that we want on the screen, like say the score, the name of our game, the words game over. Each one of those items has to have all of these things plus 2 or 3 other functions to set them up. It's like 6 things that needs to happen. You need to declare it, you need to set up the font, the string, the size, the color, and also position it. By putting all of this into this function, we can use it to declare our text and bring it down to 2 lines of code for each item. Now let's put our first text on the screen by adding a game title. But first we need a font. Create a directory in assets called fonts. Now you want to get a font. The one I'm using is royalty free. I've provided it in the GitHub. If you go to Nibbles episode 4, assets, fonts, it's called Slant Regular. When I had a look around for the license on that file, there's actually a couple of versions of it, and apparently it's derivative of some other font. I don't know. This one I've got is royalty free. So you can download that file. I think, click on it and hit download. And then you want to place that right into your fonts directory. Now, because you're dumping a file into your project, you actually need to reload your CMake project because it doesn't know about that file yet. So the easiest way to do that is right-click on your project name and go reload CMake project. I haven't put that font in yet. Hang on. I'll just copy it from somewhere else here. Copy. Paste. Okay. So reload. Alrighty, now it should be happy with that font file. Let's go back to our engine.hpp and we'll set up the font variable and our title text. So font, we'll call it main font. We'll only use one font in this game. Text, we'll call it title text. Now back over at engine.cpp, up in our constructor, underneath start the game, we want to go main font dot load font from file, or load from file, sorry. Tell it where it is. Assets, fonts, slant, regular.ttf. Now you want to go set up text. That was the function we just created. We want to pass a reference to title text. The reference just means we're not making a copy of title text, we're just sending the address of title text so that setup font can make changes to it directly. And we'll give it the font that we just set up. We'll give it the value, the title. We'll call it Nibbles. The size we'll make 28. And the color, let's make it blue. Now, because we're putting this title, we'll put it top dead center. Because objects in SFML have their origin set to the top left corner, the origin being the point that dictates where the position is. So say this square that my code is in is an SFML rectangle. The origin for this square is this corner here. So that's the 0, 0 point. And if I place the rectangle anywhere, say at 10, 10, then it's this point that'll be at 10, 10. So to center text, first we need to get the actual size of the text object. After we put a string into it and set the size of the font, we need to get the actual size of the text object so that we know how far to offset it to get it in the center. To do that, float rect, I like to call it title text bounds, title text dot get local bounds we want, not global, get local bounds. Now we need to set the position. So title text dot set position vector 2f. So to get the center horizontally, we take the resolution, divide it by 2, and then we subtract half of the width of the actual text object. So title text bounds dot width divided by 2. And the y coordinate, this may be different for you on Windows, but actually no, I think it's exactly the same on Windows. In SFML, the border on your actual window counts as pixels from the top for certain items. I don't know why, but if we set the y coordinate to 0 to try and get it at the top, it'll be down a little bit. If we set it to -9, it will actually be right up in the border where we want it. You'll see that it sits nicely in the like in amongst the top wall, and at this font size and with this particular font, -9 sits nicely. Now we need to draw our font. So we've got to draw. So we'll do it after all of our snaky stuff. Draw text window.draw title text. And that's it. If we run our game now, we hope to see a title at the top of it. There it is. See, it says Nibbles across the top, and it's perfectly centered. The font is nicely in the middle vertically. If we crash into it, it's still treated as a wall. Bam, game over. Nice. We actually used, if we go back here, we actually used, 3 lines of code to declare that text. That's because we needed to get the size of it to actually position it properly. But it's still better than 6 lines, right? Right, the next step, let's track how many apples the player has eaten. We're going to track both how many apples were eaten this level and how many total for the game. We're going to base the score on the total apples eaten. While we're at it, let's show the current level. In engine.hpp, underneath our text stuff, you see, no, up here, under the snake stuff, let's go int apples eaten this level, int apples eaten total. We'll create some more text. Apples eaten text, and current level text. Now we need to initialize these 2 variables, set them to 0. Where do you think we should do that? Over in engine.cpp. Because we want to be able to restart the game, we'll want to reset these values later. So let's do it in the start the game function. Somewhere in here, around where we set the level back to 0, let's go apples eaten this level equals 0. Apples eaten total equals 0. Now for the text, I want the current level to show in the top left and the apples eaten text to show next to it. Because the size of the current level object might change, we'll calculate the size before we place the apples eaten text. So up in the constructor, let's do some more text. Let's go set up text. If I spell it correctly, it doesn't turn red. Current level text needs to be a reference. Same font. We'll just start it as level 1 because we know that's what it'll be at the start. Size will be 28. Color will be blue. Set the position. We don't need to worry about the size of it to set its own position because it's going top left. We'll put it 15 across. That'll move it across just a little bit, and -9 again for the vertical. Now we'll actually need the size of this object so that we can place our number of apples eaten text. So let's get that now. Float rect current level text bounds current level text dot get global bounds. And let's do our apples eaten text. Apples eaten text main font, apples 0, it'll be zeros at the start of course, size 28, colour blue. Now setting the position based on the size of the current level text. So apples eaten text dot set position. This is going to be a long one, so I'll put it on 2 lines here. Vector 2f current level text bounds dot left plus current level text bounds dot width plus 20 -9. Bring that back up here so it's only 2 lines. Right, so that gets the left-hand side of it, adds the width of it, and then adds another 20 pixels. And puts it at -9. Just to show you how to do different size and position-related things on SFML objects. Now, in start the game, we want to reset these text values. So under where we change the state, let's put our text stuff. Current level text dot set string level space, and we'll just take the actual current level and throw it in there. ToString changes the current level as an integer. ToString converts it to a string so it can add it onto the end of this string. Now do the apples eaten text dot set string. Same thing again. Apples plus ToString apples eaten total. Now we need to just check that position again, just in case the size of the current level text has increased. So we can actually copy and paste that code up here. So we need this one, current level text bounds. Put that here. And then this 2-line position one here, apples eaten text. Copy that one, plonk it down there. There we go. We probably don't actually need to place the apples eaten text here if we're going to do it in start the game, but start the game is run before we place all of these. All right, we have the texts, but we need to update them when the level changes or when an apple is eaten. Let's update the apples eaten text now. So over on update.cpp, have a look at the collision for apples. Here we go, collision detection apple. Remember we've got this to do here. Apples eaten we're going to do now. Apples eaten this level plus equals 1, so we'll increment it by 1. Apples eaten total plus equals 1, do the same thing. Apples eaten text dot set string apples, same as what we did in the start of the game function, ToString apples eaten total. Then we need to do the same 2 position things, so let's just grab them from our engine CPP. We need to do that float rect and that position thing there. Back into update, plonk them in there. Now we need to draw these texts. So go to draw, and let's go window.draw current level text, and window.draw apples eaten text. Now let's test it. Now you can see the current level and the apples eaten. Let's check if it increments and check if it resets when we restart the game. Apples eaten went to 1. Bam. All right, I'm going to restart the game. Nice. Apples went back to 0. Nice job. Now let's get score added. Then after that, we can work out how to load the next level. In engine.hpp, we want to add something to store the score in. Because the score could be huge, let's just allow it to be huge. Let's go overboard. Unsigned long int score. Unsigned just means it can't be a negative value. And it also allocates more, allows it to be double the size of a signed value. So it can be even larger. We need some text to hold our score in. Score text. Alrighty, engine.cpp. Back up in the constructor. We want to place the score text at the top right. So as we set it, and after every time it updates, we need to recalculate its size and position. Because remember, we get the position from the top left, and if the score extends to the right by getting larger, we need to be able to move it over a bit. So let's first set it up. Score text, just the same as we did the other ones. Main font. We'll do toString score 28 size color blue. This time we're just doing the toString thing straight away instead of just saying it's 0. Then we need to get the size. Float rect score text bounds equals score text.get local bounds. Score text.set position vector2f resolution.x minus, so the resolution.x is the horizontal resolution, so 800, and then we want to go minus the width of our score text, so score text bounds.width, and then we want to go a little bit further, so another minus 15, and then the y coordinate is -9 like the rest of them. Down in start the game, right at the top, let's set the score equals 0. Then we need to update the score text. So under the apples one, we'll go score text.set, same as what we're doing with the other ones. Set string to string score. Then we need to get the size of it so we can position it again. Float rect. Let's just grab it from up here. Grab the two sizing ones from the score. Plonk them in there. Now, every time the snake moves, we want to increase the score. So back in updates.cpp, we need to update the score. Now, in our collision detection for Apple, in our to-do, we say update score, but we actually want to do that outside of here. So we'll just update that to-do, and then we'll roll up here. Let's do it under the direction changes. We'll run update score. Every time the snake moves, we'll increment the score. So the longer you're alive, the more score you get, instead of just getting score when you eat apples. So score plus equals snake.size, we're going to base it on the size of the snake, times apples eaten total plus 1. I'll put plus 1 there because at the start of the game we have 0 apples eaten, and 3 times 0 is what? 0. So we don't want to be getting 0 score at the start. So we're going to put 1 there to start with. That'll get us rolling with our score, and it'll increment past that. We need to set the actual text. Set string to string. We're typing the same stuff over and over here. It might have been a good idea to make a function to update the score text. Anyhow, we'll keep on. We're using the same thing that we did back in here to get the size and the position. So let's just copy and paste it. Save our fingers. Bam. Score text. We get the size of it and we set the position. Nice. Let's go to draw and actually draw our score text. So window.draw score text. Now we can test it and see if we've got a score. There we go, we've got a score. It's incrementing every time the snake moves. After we eat an apple, the snake will grow and the amount that the score increments should increase. I'm gaining more points per step now. Now we want to actually test if we crash and restart the game, does it go back to 0? Sure does. Nice. So there's just 2 more parts to add to our game. We need to increase the level when we eat enough apples, and we need to add a game over screen. Let's look at loading the next level. Back in engine.hpp, most things start in engine.hpp. And we'll need a new function called begin next level. Put it down here just above start the game. Begin next level. Engine CPP. One thing we need to remember to do in start the game, before we load a new level, we need to clear out all the walls from our current level. So at start the game, we should clear our walls, because if we progress to, say, level 2 or level 3, crash and then restart the game, we need to make sure we wipe all those walls and load fresh ones. So while we're clearing things here, let's put wall sections.clear. Now let's do our begin next level function. I want to put that straight under the start the game function. Begin next level. Let's put a comment on it. So we're going to increment the level number, load the next level, and reset the snake. So current level plus equals 1. Wall sections will clear here as well. So every time we load a new level, we have to wipe the old one. We're going to clear the direction queue so we don't come into the new level with a whole heap of crazy directions queued up. We're going to change the speed. I'm going to set it back to the starting speed plus current level. So if we get to level 2, the speed will start at 3. If we get to level 3, the speed will start at 5. Set our snake direction. direction right. Set our sections to add back to 0, just in case we thought it was going to grow. Need to start our snake fresh on a new level. Apples eaten this level, reset that back to 0. Now we need to load level, current level. Now we need to set a new snake and move the apple. So we reset the apple position. We also want to change the level string. We can steal that up here from the start the game function. Bam. We want to get the size of the current level and set the position of the apples eaten text. So we'll grab those two. A lot of this function is similar to the start the game function, but we're not resetting absolutely everything. Right, so when we begin the next level, we increment the level number, we clear out all the walls, clear out the direction queue, we reset the speed but make it a bit faster, reset the snake, and the apple's eaten. We load the new level, create a new snake, move the apple, and adjust our text. Let's move over to update and look at our apple collision. Now the to-do, check if it's time for the next level. Let's do that. So after we've done all this text stuff, before we go increasing speed and adding sections to the snake, let's check if we actually want to load another level, if we've eaten enough apples. We'll use a boolean here, beginning new level equals false. So we assume that we're not beginning a new level. If apples eaten this level is greater than or equal to, we'll make it 10. So if you eat 10 apples, we'll move on. Begin the next level if there are more. Otherwise, just stay on the last level and keep getting harder till we die. So if current level is less than max levels, so if there's more levels to go, then beginning new level equals true, and we'll run begin next level. Now, we only want to run these bits if we're not beginning a new level. So that's why we've done this Boolean thing. So if not beginning new level, then do these things. Now, we only have one level file, so our game will just stay on that level forever. We need to create or copy another level file, a bit more difficult than the first one. Luckily, on the GitHub, we have a second level. So if we go back to Nibbles 4, Assets, Levels, you see levels2.txt. Let's have a look at it. It's only slightly more difficult than the first one. Copy it. Go back to our project. Now, in our levels folder, we need to create a new file. Call it levels2.txt. No, level2.txt. Paste in what we just got. If you actually copied that file from the GitHub instead of creating it, then you'll have to do a reload CMake again. Now, one last thing we need to remember to do is update our manifest file, levels.txt. Otherwise, the game won't know about it. So we just added level2.txt. There we go. Now we can test our game, and we'll see if we can eat 10 apples and load the next level. When we die and restart the game, it should reset back to first level. Alright, I might speed this up for you in the video. There we go, loaded the next level. We started out a little bit faster this time. And on this level, there's a wall in the middle. Let's try and crash into it. Bam. Game over. Now, if we press enter, it should reset back to the first level. There we go. Nice. Now let's add one final touch. That's a simple game over screen when the snake dies. We'll just draw some text over the game window saying game over and press enter to try again. But because we're adding this text directly over the game field, we don't want the text to clash with the background objects, so we'll add a bit of a border to the text. Over on engine.hpp, we'll add our text items. We want game over text and press enter text. Let's go and set them up. Up in our constructor, set up text, game over text, same font. We'll have it say game over. Text size will be 72 this time. Let's make it big. Color, and we'll make this one yellow. Now we're going to need the size of it because we want to put it in the center horizontally. Game over text bounds equals game over text dot get local bounds game over text dot set position vector 2f resolution dot x divided by 2 minus game over text bounds dot width divided by 2. And then for the y coordinate, let's make it 100. So down the page a little bit. Give it a color. Dot set. Sorry, let's give it a border. Set outline color. We'll make this one black. And if we don't give the border an actual thickness, then you won't even see it. So outline thickness of 2, just a little bit of a border around it. Let's do our press enter text. Set up text. Press enter text. Main font. We'll have it say press enter to try again. Size 38. We'll make this color green, which is actually the same color as our snake. So if the game over happened while the snake was in kind of the center of the screen, then maybe the text would clash and you wouldn't see it properly. So putting the border on the text helps to make it more visible. We also want this one centered, so we'll need to get the size of it. Flight rect. Press enter text bounds equals press enter text dot get local bounds. press enter text dot set position, same as the other one, vector 2f resolution dot x divided by 2 minus press enter text bounds dot width divided by 2, and we'll put this one at 200 on the y coordinate. What have I got wrong there? Oh, I've put a closing bracket here. That was wrong. I've accidentally put the 200 outside of it. There we go. Now the border, press enter text dot set outline color black, and press enter text dot set outline thickness to 2. Now we need to draw it, but we don't want to draw it all the time. So draw game over. So if current game state is equal to game state game over, then we can draw it. Game over text and window dot draw, press enter text. Now let's test the game again. Now if we crash, we should see a game over screen. Bam, that's better. Now we've got some indication of what happened when the game stopped. If we press enter, it should just disappear. We'll see if we can die in the middle somewhere where the press enter text is. It's around here somewhere, right? Oh, missed it. I want you to see the border on that text. I think you can see the border on the game over part anyhow. No, it's black, you can't see it. So it's up here a bit. Bam, there you go, you can see the borders, so the text doesn't get obscured by the stuff that's in the background. Nice. Now this actually concludes this tutorial. We now have a complete game. Sure, it's not super exciting, but hopefully we learned something along the way. Now here's some homework for you. Up until now, you've been copying my code. The next step is to increase your understanding of it by making some changes and improvements. As you make these changes, it'd be awesome for you to show me your code. So upload your game to GitHub and post a link to it in the CT community at forums.caf.tech. Here's some ideas to get you started. Try changing the required number of apples to eat before the level changes into a variable in the engine class and change it to 5. So instead of hard coding that number of apples to eat, make it a variable and put it in the engine class and then set it to something different. Next one is make it so the speed only increases when you load a new level. So start the speed a bit higher on level 1 so it's not super slow, but don't increment the speed when you eat an apple. Wait until you load another level to increase the speed. That's actually the way that the original Nibbles game worked. Next, you could add a couple of cheat keys. Maybe pressing space adds more sections to your snake. Maybe pressing M moves the apple somewhere else. And maybe pressing L just loads the next level. Here's one. Can you find code that we never actually used in the game? Or do you have any ideas on how to improve the code? I have some ideas, but I'd like to see yours. And the last one is your choice. Have fun. I'm excited to see what you come up with. Maybe another idea would be to change the level files to include the actual snake. You could use the H to indicate where the head would be and S to indicate the sections of the snake's tail. And that would give the game the starting position of the snake. You could use that to put the snake wherever you like in your new level, and also make it as long as you like. So maybe some levels you start with a really huge snake that's already wrapped around everywhere. That'd be a cool idea. Now that you've come this far, why not take your learning further? Having C++ experience is very highly regarded in any programming job, including AAA game development and even app development. It's the language that spawned many others and is to this day hard to beat performance-wise. Here are some resources you could use to help push your skills further. I didn't really explain the very basics of programming, so maybe for you, a beginner-style book would be helpful. One book which helped me get started with C++ and SFML was Beginning C++ Game Programming by John Horton. It starts out very basic and brings you through the core features of C++. You'll make several games during that book. It's quite fun. Next is a sort of C++ reference book. It's not really a tutorial, it's more of a quick introduction to each concept with a really nice glossary at the end. I find these books very handy when I'm stuck on a problem and can't remember how a certain construct is supposed to work. This book is C++ Programming in Easy Steps. I actually have 7 in Easy Steps books. I like that they get to the point and move on. Online, we have sites like cppreference.com, some very detailed explanations and examples of just about everything to do with C++. Then there's cplus.com, another great reference resource. For SFML specifically, just go to their website and check their documentation and tutorials. They have some book recommendations too, but at least one of them is simply their documentation printed and shipped to you. If you find any more resources that you found very useful, or you've got some suggestions, feel free to let me know in the comments or over on the forums. Thank you very much for watching. I hope I've managed to teach you something without boring you too much. I actually had a lot of fun developing and recording this. Please consider hitting that subscribe button, and if you can, I would really appreciate your support on Patreon or Ko-fi. You can also come and join the community at forums.caf.tech. It's the best place to go to ask for help with any of this code or check out my other projects. Would you like to create this same game in a different language? Which language would you like to see a tutorial in? JavaScript maybe? Thanks for watching. Stay caffeinated.